Okay, in our previous section, we talked about simple random sampling. Well, today we're going to talk about some other sampling methods. And so this is section 1.3. But first, let's look at the drawbacks to simple random sampling. Um, it's the most natural form of sampling, okay? There are some drawbacks to it, however. Like it fails to cover subpopulations. Like if you wanted to break it down into subcategories, it would fail to cover that. It's just because everybody's equally likely, so everybody's thrown into a hat and pulled out, so to speak. It may be impractical uh, because your population may be huge and it may be scattered, and it just may be hard to get everybody, quote unquote, in a hat so that you can draw it out. So we need some other sampling designs that are more appropriate for these common issues. So the first thing we're going to do is we're going to look at systematic random sampling. So what you want to do is you want to divide the population by the sample size and round down to the nearest whole number. Use a random number table or another similar device to obtain a number k that is between 1 and n. Select for the samples those numbers of the population that are numbered k, k plus m, k plus 2m. Continue until the sample size is met. Okay, so let's look at an example of this. Professor Pythagoras wants to sample 15 of 728 students enrolled in college algebra. Use systematic random sampling. Um, use systematic random sampling to obtain the sample. So, step one. Okay, step one says, because it's a systematic, we take the population size, which is 728, and we're going to divide it by the sample we want, which is 15. So remember, you round down, so this is going to give you approximately 48 when you round down. Okay, approximately 48. All right, step two. Step two is to use a random number table or similar device to find a number between 1 and 48. So we want, that's step one. Step two, find the number between 1 and 48. And you want to use your random number table to do this. So let's suppose using a random number table, we got 22. This number is called k. Find a number, and this number here is called k. So let's find a number between 1 and 48. So let's suppose k is 22. I just randomly chose that. Let's suppose you chose it but you would be choosing it. You wouldn't randomly choose it. You would choose it from a random number table, randomly. Okay, so let's suppose that we have randomly chosen this using the random number table. So 22 would be our starting point. Okay, now you want to select those members of the population that are numbered as k, k plus m, k plus 2m, and so on. Now, what is m? 48. 48 is m. So in step 3, k is 20. So we want to choose numbers like this. K would be our first number. K plus m, the second number. K plus 2m, the third number. K plus 3m, the fourth number. All the way until we get our sample of 15. Okay? Well, our k is 22. So k plus m. Well, m is 48. So 22 plus 48 gives me 70. K plus 2m. Okay? 2 times m, 2 times 48 is 96. 96 plus 22 gives me 118. Okay? Okay? 3 times m. So that's 144. So K plus 144. So 22 plus 144, 166. So what would our next one be? In your mind, go ahead and select the next one. Okay. So we are simply going to take 166. In case you hadn't figured this out, we're just adding 48 each time. So in case you hadn't figured that out. So we're 166 plus 48 would give me 214. 214 plus 48 would give me 262. 262 plus 48 would give me 310. 358. So you see how we're going on this. And you would continue until you got to 694. 694 would be your 15th member of that sample. So what you would do is once you had all these, you would pick all the members of the population that correspond to these numbers. That would be your sample. All the members of the population that would correspond to those numbers. Whoever's number 22, number 70, or whoever's number 694. So that would be how you do a systematic random sampling. A lot of times when people are looking to call you, like telemarketers, they like to use the systematic random sampling sometimes. Okay, so that would be an example of how it is used. But that would be systematic random sampling. Not systematic. Yes, excuse me. I get confused myself there. So there's so many sampling methods. I think I'm getting ahead of myself sometimes. But yes, that is systematic random sampling. All right. So the next one that we're going to look at is called cluster sampling. And cluster sampling, you divide your population into groups. You number, those groups are called clusters. You number the clusters and obtain a simple random sample from the clusters. You use all the members of the cluster obtained in step 3 as the sample. Okay? So, for instance, to save time, the planner decided to use cluster sampling. The residential portion of the city was divided into 947 blocks. So this is the city planner dividing a city into 947 blocks, each containing 20 homes. Each containing 20 homes. Explain how the planner used cluster sampling to obtain a sample of 300 homes. So, we have 20 homes per block. So the first thing, step 1, we're going to do, the planner would take the 947 blocks as clusters, thus dividing the population of the city into 947 groups. So this part right here, this is step 1. Step 1 is the 947 blocks, because the planner has already done this for you. This is your clusters. So you have 947 clusters here. Okay? He did that for you. He went ahead and divided that up for you. All right, so what you're doing is you're looking at a range of 1 cluster to 947 clusters. So you want to use a table of random numbers or a random number generator or some other method of finding random numbers, and you want to let's obtain a sample of 15. Let's obtain a sample of 15. Okay, so we want to obtain, so step 2, we're going to obtain a sample of 15 using a random number table. Okay, it's find a sample of 15 Now these are 15 blocks, okay, using a random number table. So we have 20 homes per block. So we have 15 samples that we would get from the random number table times 20 homes per block, which was given in the problem here. So that would be 300 homes. So that would be how you would determine your sample of 300 homes. So basically, here's what we did. The planner used a cluster sample to obtain a sample of 300 homes, 15 blocks of 20 homes per block. So each of the three interviewers was then assigned 5 of the 15 blocks. This method gave each interviewer 100 homes, but saved much travel because the interviewer would complete the interviews on an entire block before driving to another neighborhood. So this would be a way to, and this example is in your book, by the way, and this would be a way to save time, because what the planner did is he took the residential portion and divided it up into clusters, which were blocks. Each block contained 20 homes. Now, we sampled 15. Now, how did we determine the sample of 15? Well, if there are 20 homes in a block, 20 times 15 is 300. So we knew that we needed to sample by the problem. The problem told us we wanted a sample of 300 homes. So I knew 15 times 20 was 300. So we needed to find a sample of 15 blocks. Remember, these are 15 blocks here. That's your clusters. And so we had 15 blocks times 20 homes per block gave you your 300 homes. And that's how we would use cluster sampling to find those 300 homes. So all you would have to do is, like I said, you would take your person, whoever's doing the city planner, and if you had all it would take was 3 people, and you could assign 5 of the 15 blocks. Each person could have 5 blocks, and that would give each person 100 homes. And so it would save a massive amount of time and money, because you wouldn't have to be driving here, there, and yonder. You would be able to do a whole block, then go to another whole block, then go to another whole block. So that's the means of cluster sampling. Cluster sampling, dividing into clusters, using the clusters to help find the sample like we did there. All right, stratified random sampling. Divide the population into subpopulations. Now these subpopulations we're going to call strata. Determine how many items or subjects should be included in each sample from each strata. To determine how many of each stratum are to be sampled equals total sample size times the strata size divided by the total population size. And I know this is all Greek. We'll work it out here in just a minute. Each member in the stratum will be numbered off 1 through the total strata size. Randomly select the members from each strata that will be used to make up the sample. Alright, so a town has 250 homeowners, of which 25, 175, and 50 are upper income, middle income, and low income, respectively. Explain how we can obtain a sample of 20 homeowners. Okay, explain how we can obtain a sample of 20 homeowners using stratified random sampling with proportional allocation, stratifying by income group. Okay, so step one. Step one was stratified, is we want to divide the population into subpopulations. Well, this was basically done for us. So we want to find out what our strata are. Our strata in this case are upper, middle, and lower income. Okay, that would be our strata. So we have three strata. From each stratum, stratum is the singular form of strata, from each stratum, obtain a simple random sample of size proportional to the size of the stratum. That is, the sample size for the stratum equals the total sample size times the stratum size divided by the population size. Okay, so that's a lot of Greek to tell you this. We want the samples to be proportional. Okay, we want the samples to be proportional. So we've got 20 homeowners here. We want that we're trying to take a sample of. We don't want to take 10 from the 25, 9 from the 50, and 1 from the 175, obviously, because 175 has the majority of the population. So you want it to be proportional based on the size of the population that you're, or the sample that you're trying to obtain. So here's what we do. All right, so of the 250 homeowners, 25 are upper, 175 middle, 50 are lower. So for the upper income, so I'm going to use UI for upper income. So for the upper income, we do the total sample size, which is 20. Total sample size times the number of upper income over total homeowners. Total homeowners. So for this particular one, the total sample size is 20 times the number of upper income, which would be 25, divided by the total sample size, which is 250. Okay? So 20 times 25 divided by 250 gives you 2. So what that tells me is that I want to take 2 samples from the upper income because it has notice it has the smallest amount of people in that strata. So it is going to have the smallest sampling from it. So we want 2 from it. Okay? Let's look at the middle income, and we do it in a similar fashion. So we do total sample size times the number of middle income, which is 175 over 250, which equals 14. So we're going to take a sample of 14 from the middle income strata. All right, let's do the lower income strata. So that's 20 times 50 over 250, which is going to be 4. So we're going to take a sample of 4 from the lower income strata. Now, use all the members obtained in step 2 as the sample. So what we're going to do is we're going to take a simple random sample of 2 from the upper income, 14 from the middle income, and 4 from the lower income. Now, how are we going to take that simple random sample? You can put them all in a hat. You can randomly draw them using a number table. You can use a random number generator with your calculator. There are several ways to do that. So, but what you're going to do is take 2 from the upper income, 14 from the middle income, and 4 from the lower income. That's how we would obtain a sample of 20 homeowners using proportional allocation by stratifying. Now, what stratifying does? Conclude this up. We break it into strata. We take the strata, and using our formula here, right here, total sample size times the number in that particular strata over the total. So these were the numbers in the strata. This was the total. And you're going to get a proportional allocation of how many you should sample from each strata. Now, when you're done with this, notice 2, 4, 14 gives me 20. That should be the case, okay? When you're done, you should be able to get your 20 from proportionally allocated from each strata, okay? From each stratum. And notice the smallest one had the smallest number, the largest one had the largest number. That should be the case. Now, how you would get those 2, 4, and 14, we would look at the upper income and you would use simple random sampling to get it. We would look at the middle income, we'd use simple random sampling to get those 14. We would look at the lower income and we would use simple random sampling to get those 4. Any way you want it, whether it be putting them all in a hat or whether it be a random number table or a random number generator. Okay, and we haven't done random number generator just because I know not all of you have the calculator capabilities to do that. But it is possible on your TI calculator. By all means, look at that. It's a good thing for you to do. Okay, so that would be stratified sampling. That's how you would use it to do a simple random sample of each of the stratums. Now, we don't do very much large-scale sampling in this class, but I do want you to know how it's done. Most large-scale surveys are going to use a combination, okay? When you have a large scale of things, it's going to be hard to use just one of these because just one of them may not work right. So you may have to use stratified sampling. Then in each strata, you might have to use systematic sampling. And then in each system, you might have to use simple random. I mean, there's so many ways you could use that. We call this multi-stage sampling is what we call it. And we use it a lot by pollsters and government agencies when they're doing all these surveys and statistics. So, but we don't do many of those in there, but I did to make that known to you. All right, if you have any questions, please ask your instructor. I know some of this is kind of abstract and hard to understand over a video, but we're going to do the best we can on these first 3. Like I said, this is all terminology and theory, so it's harder to understand over a video, but please read in your book because most of these examples do come from your book and you're able to read and repeat what I've done in these videos, okay? So have a good day. Let us know if you have any questions.